So today I want to talk about a fairly interesting integral. Suppose we wanted to find the indefinite integral of 1 over x times the square root of 1 minus x to the fourth. We have this weird square root of 1 minus x to the fourth term in the denominator, and I could definitely try substituting u equals x squared, but I'm actually going to go ahead and substitute u equals 1 minus x to the fourth, just so I can simplify the entire square root expression in the denominator, and see what happens to the rest of the expression. If we let u equal 1 minus x to the fourth, then du is equal to negative 4x cubed dx. And if we divide negative 4x cubed on both sides of this relation, we get that dx equals negative 1 over 4x cubed du. If we substitute this into the expression, then this becomes the integral of 1 over x times the square root of u, since the square root of 1 minus x to the fourth just becomes the square root of u, and we still have the dx term, which is equal to negative 1 over 4x cubed du. So this becomes the integral of 1 over x times the square root of u times negative 1 over 4x cubed du. And if we multiply the two terms together, this simplifies to 1 over negative 4x to the fourth times the square root of u du, and I'm going to keep the negative sign in the denominator, and you'll see why in a second. This expression is not yet fully in terms of u, and we need to write the negative 4x to the fourth in the denominator in terms of u. So since we let u equal 1 minus x to the fourth, if we subtract 1 on both sides of the relation, we get negative x to the fourth equals u minus 1. If we substitute this back into the integral, this becomes the integral of 1 over 4 times the square root of u times parentheses u minus 1 du, since the negative x to the fourth just becomes parentheses u minus 1 as a factor in the denominator. The square root of u in the denominator stays the same, and the 4 also stays the same. Alright, so if we observe the integrand, we'll see that the u minus 1 term can be expressed as square root of u all squared minus 1. So we might want to do another substitution with v equals the square root of u. The derivative of the square root of u is 1 over 2 times the square root of u, and we actually have a square root of u term in the denominator, which is good, but it has a coefficient of 4 in front of it instead of 2. So here's what I'm going to do. Why don't we just take out a constant of 1 over 2 and rewrite this as 1/2 times the integral of 1 over 2 times the square root of u times parentheses u minus 1 du. And now we're ready to substitute v equals the square root of u. If we let v equal the square root of u, then dv is equal to 1 over 2 times the square root of u du. And if we just substitute this back into the expression, we get 1/2 times the integral of 1 over v squared minus 1 dv, since the 1 over 2 square root of u du becomes dv, and u minus 1 can be expressed as the square root of u all squared minus 1, and since v is equal to the square root of u, the u minus 1 term just becomes v squared minus 1. We can factor the denominator and express the integrand as 1 over v plus 1 times v minus 1. And now we're just going to have to do partial fractions to split this into two smaller fractions. So here's how we do the partial fractions. We start with 1 over v plus 1 times v minus 1, and let that equal a over v plus 1 plus b over v minus 1. Since the denominator is a product of two distinct linear factors, then solve for the coefficients a and b. If we multiply both sides by v plus 1 times v minus 1, we end up with a times parentheses v minus 1 plus b times parentheses v plus 1 equals 1. If we plug in v equals 1 to the expression, we end up with the equation 2b equals 1, which implies that b equals 1 over 2. If we plug in v equals negative 1, we get the equation negative 2a equals 1, which implies a equals negative 1/2. If we plug these values back into the equation, 1 over v plus 1 times v minus 1 equals a over v plus 1 plus b over v minus 1, then we can infer that the original expression is equal to negative 1/2 over v plus 1 plus 1 over 2 over v minus 1. And this is the same as negative 1 over 2 times parentheses v plus 1 plus 1 over 2 times parentheses v minus 1. So if we go back to the integral, we can rewrite the integrand as negative 1 over 2 times parentheses v plus 1 plus 1 over 2 times parentheses v minus 1. If we integrate each term separately, then the integral of negative 1 over 2 times parentheses v plus 1 is negative 1 over 2 times ln of the absolute value of v plus 1, and the integral of 1 over 2 times parentheses v minus 1 is 1/2 times ln of the absolute value of v minus 1, and all of this is multiplied by a constant of 1/2, since we have a 1 over 2 constant before the integral, and we also have to add the constant of integration c. If we expand the expression, we end up with negative 1 over 4 times ln of the absolute value of v plus 1 plus 1 over 4 times ln of the absolute value of v minus 1 plus c. We originally substituted v equals the square root of u, so if we substitute the square root of u back in for the v, this becomes negative 1 over 4 ln of the absolute value of the square root of u plus 1 plus 1 over 4 times ln of the absolute value of the square root of u minus 1 plus c. We also substituted u equals 1 minus x to the fourth. So if we substitute that back into the expression, we get negative 1 over 4 times ln of the absolute value of the square root of 1 minus x to the fourth plus 1 plus 1 over 4 ln of the absolute value of the square root of 1 minus x to the fourth minus 1 plus c. So as you can see, the final result is a fairly big expression.